Hi, grade 11s. Glad that you are able to tune in to today's lesson. Unfortunately, I'm not there today, but I wish you all the best today and wish I could be there because this really is one of my favorite lessons because it's kind of where everything comes together. So, what I would like to do, and I think that needs another heart because that's beautiful. Okay, so what I would like to do is I would like for you to write out your special triangles from last class. So use your notes however you want, but I would like 2 special triangles. Remember, I want the one that has a 45-degree angle in it, and I would like a triangle that has our 60 and 30-degree triangle within it. So pause the video, please, and take your notes out and with a friend see if you can complete the side lengths for that video. So what does it look like? What are the side lengths in that ratio? So pause and then tune back in. Here in the first triangle, both my side lengths, the arms of the right triangle, are 1, and my hypotenuse is a root 2. In the other triangle, 1, 2 is the longest hypotenuse, and root 3 is the other length. So 1 root 3 for these arms and 2 for the hypotenuse. What I would like you to do now is just with that image above, and I'm just going to shift them up so you can kind of see them while I go to scroll up. We'll move the S there as well. As I'd like you to envision this as a quadrant. Okay, that's not very straight. Okay, and through here as well. Perfect. Whew, like that. This is our x and this is our y. Now in this case, x is really our cosine, and I'll tell you about that in a second. For now, just take my word. And the y is my sine. Now one thing I want to notice, remember our cast rule from the other day. So C, A, S, T, which told us which functions were positive. So in the fourth quadrant where the C is, cosine is positive. The first quadrant, A, everything is positive. Sine is also positive in the third quadrant, or second quadrant, pardon, and tangent is positive in the fourth quadrant. Now, here's what I would like you to do. We're going to envision 3 triangles. An orange triangle, and actually I'm going to make that thinner just so I'll be able to kind of, that's not quite thick enough. 3rd time's the charm, right guys? And we'll go with this one. Okay, perfect. Envision this triangle. This is going to be my 30-degree triangle. Well, 30 degrees from what? It must be from 0 degrees here. So think of this inside as that 30-degree angle. The next triangle that I'm going to envision, and remember it looks just like the one below, relative to that. So from 30 degrees, so from this viewpoint here, that 30 degrees, cosine is adjacent over hypotenuse. So what I want you to write down is at this point here, root 3 adjacent over hypotenuse. That's cos. Now, why did I write it as that here? And if I look from 30 degrees, the sine of 30 degrees is opposite over hypotenuse. So that will be my 1/2. Again, why did I write it cos comma sine? Anytime I have a point on a specific unit circle, the x coordinate is always the cosine of that angle. So by looking at this graph called the unit circle, the cosine of 30 degrees is root 3 over 2. If I look at the y component, the sine of 30 degrees is 1/2. So it's a nice way that tells us about, that tells us about different angles on a perfect unit circle, remember, that has a radius of 1. So if I were going to take a second and fill in other points that I know on the circle already, I know this point, if it has a maximum radius of 1, x, I'm going 1 unit to the right and 0 units up. At this point at the top, 0 units to the left or right, 1 unit up. Maximum radius of 1, 1 unit to the left, -1, and 0 up or down. And this is the last one, 0, -1. So those 4 points were nice to find. What you will see now is that I actually have a second triangle to visualize. This second triangle is at 45 degrees. So using my special triangle below, I use that same idea. The cosine of 45 degrees is √2 over 2, comma, sine of 30, which is √2 over 2. It's the same. So that's the coordinates of that point. The last triangle we'll just visualize, we'll make it a green triangle, is, as you probably guessed, our 65-degree triangle. Or sorry, 60-degree triangle, not 65. Our 60-degree triangle. At that point, the cosine of 60 degrees is 1/2, and the sine of 60 degrees is √3 over 2. Now here's what I want you to do. We're going to envision that 60-degree triangle. Don't write the remaining colors in, so just keep the colors in the first quadrant. Hopefully we can all agree that this is also 60 degrees. This interior angle is 60. Well, that means that this terminal arm, this terminal arm is 60 degrees off of 180, which means that it is at a angle initially of 120 degrees. I'm going 2 60-degree motions to get there, which means at this same point I have the exact same triangle. My coordinates, my sine and cosine ratios are the same. So the cosine again of 60, which is, hey, the same as the cosine of 120, is 1/2. And the sine is √3 over 2. Now, before you say anything, I have to deal with sine. In the first quadrant, my x is positive and my y is positive. In the second quadrant, my x is negative, my y is positive. The same occurs here. X, which is cosine, is negative. Sine is positive. I'm going to go back and I'm just going to, before we move on, label all the different angles in my unit circle. So I got to 120 degrees. This is 135, 150, and I get all the way to 180. From there, I want to go 60 degrees more to get to 210. Remember, 45 degrees in the middle, so 225, 240. So that 240 is 60 degrees off of 180 versus the 210 is 30 degrees off of 180. I get to 270 in the middle. 60 degrees off of 360, I'm at 300, 315, and 330. Now, getting used to doing those degrees around the circle takes some time, but you'll get there. So we did our first, again, don't write these green parts, green triangles. If I go and I look for my next 60-degree triangle, you'll notice it's here at 240, just like my other 60-degree triangle is there at 300. Those are all the same points. So I can write on my unit circle the points here, 1/2, √3 over 2, 1/2, √3 over 2, and just recall that I need to adjust the sign. In the left quadrant, negative, negative. In this quadrant, positive, negative. So negative, negative, positive, negative. I've completed all the 60-degree triangles. I can now look for the blue triangles. They're the middle ones. So all of my middle ratios are the same. So we go around and we write the middle ratio in root 2 over 2 for cosine of 135 in this quadrant, comma root 2 over 2. Adjusting for sine, negative. And in this quadrant here, both will be negative, root 2 over 2, root 2 over 2, negative, negative. And in the quadrant over here, root 2 over 2, root 2 over 2, positive, then negative. The very last ones you can see will be your 30-degree triangles, which are the bottom ones. Oh, that one should have come out here, sorry. And this one here. So filling in these points, and I'll go a little bit faster, they're going to match the same. Root 3 over 2, comma 1/2, negative, positive. This point here, root 3 over 2, comma 1/2, negative, negative. And the last one, yahoo! Root 3 over 2, comma 1/2, positive, negative. Give yourselves a round of applause. You have now completed your first unit circle. Yay! Now what I'm going to do is I'm just going to get this special triangle stuff out of the way so it looks a little, first I can squish it down, a little less jammed here. Now what I'm going to do, this is your unit circle. What it tells you is relevant ratios. I could ask you, what is the sine of 150 degrees? So I find my unit circle, I find 150, and I know that sine is this one. It's always the second coordinate, the y coordinate. Now how can I remember that? And this is key. My coordinates are always cos, comma, sine. They go alphabetically. C comes before S. So what is also nice is that this tells me my different ratios. I can see which is positive and negative. I can look at my fourth quadrant and see quickly and easily all of my special ratios for sine are negative. All of my cosine ones are positive. So what I would like you to do using this is I just want us to look for a minute or so about some patterns that I see to help you with preparing this in the future. Okay. You will not be given a unit circle, which I know, don't worry, don't freak out yet, but you will be given a blank one, and you're going to get used to in time filling it in. So here's how to look. It's just about looking at the first quadrant. If I start at the x coordinates on the way down, 1, 2, 3. Okay. What's nice about that is it's really the square root of 1, the square root of 2, the square root of 3, because the square root of 1 is 1. All of those terms are all over 2. If I look on the second quadrant, the outside terms, the x's, are the same. 1, 2, 3. Positive on the right-hand side, negative on the left. If I go back, I can also see from right to left, 1, 2, 3, top to bottom, sorry, and then 3, 2, 1. So 1, 2, 3, 3, 2, 1. Same pattern here. 1, 2, 3, 3, 2, 1. All of the terms are all divided by 2, so we don't need to remember that. If you look at the bottom, there's actually a different pattern, which is the ratios are flipped. If I look at the outside, I go from 3, 2 to 1. 3, 2 to 1. Instead of 1, 2, 3 from top to bottom. You can also see on each side 3, 2 to 1. Again, 1, 2 to 3. So if you can remember that the third and fourth quadrant, the orders are flipped, that's kind of a handy thing to have. So what I would like you to do, keep this unit circle, and for the rest of the unit, you want to have it with you at all times. Okay, we will be practicing next class filling in another one, but still using this as our base one. So 2 different things that you are doing right now for your class tasks. The first one is our IXL problems. I really recommend that you try these out. And actually, I'm going to take this back and I'm going to say that this is the second option. Okay, so I'll make that little 2 in there. IXL problems on Moodle as a link. Try a few out. The first thing I want to do is a unit circle game. Okay. What you're doing in this game is you're going to match the different points. And before I show you how to do that, I'm just going to write down your homework, and thinking now that I have erased your homework, I just edited it, which is up on your Moodle page. So if you were to check Moodle, you'll see that you have page 238, numbers 3, 4, 5, 6, 7, 10, and 16. Okay, so there's a few problems on this, but it's really good work, and a lot of it is what is the sine of 180 or what is the cosine of 240. So a lot of it is more straightforward. But in terms of our circle game, okay, this is what we're going to focus on. Ready? So we're going to go to our Moodle page. Moodle. And hopefully that comes up for me. Moodle.ashbury, great. Sign in. Et voila! Here is your Moodle page. So, zoom in, lesson 6, that's today. Click the link for the unit circle. Let's try. And just as an FYI, see the IXL problems on the right there, give them a shot. So click the link. Click the link. And amazing, it takes me to the math warehouse. I scroll down just a little bit. This is my game. This is what's fun. Now, before I show you how awesome this is, and I think that you will get a little competitive, I want to show you an image that hopefully doesn't make you cry. Are you ready? It's this. This is a unit circle, but with something called radians. Radians are just different versions of degrees. If I were to look here, pi over 3 radians is 60 degrees. It's a fancy mathematical way to say sections of a circle, right? Like 60 degrees is a portion of a circle. I can represent that as pi over 3. So using this, you need to keep it up on your screen. I do not expect you to understand radians at this point. If you do, awesome, you're the best. But if you don't, not a problem. So keep this up on your screen. What we're going to do is we go to our quiz, and we hit Start Game. Notice what popped up in that little white box. It says 5 pi over 4. So because I have this up on my other page, I see that 5 pi over 4 is at 225 degrees. So on this map that I started, 225, I hit pi over 4. Whoo, it's green because it's right. Then it says, where is pi? Well, this will be at 180. Use your other image. Okay, notice it's changing. Where is 0, 1? Right? Remember, that's your coordinates. X, 0, 1, up. That'll be this point here. 7 pi over 4, we check our chart. 7 pi over 4 is at 315. 315, 7 pi over 4, great. And this is just giving me the exact same one over and over. I really do want you to see something else. 1, 0, x, y, 1, 0 as my point. Oh my goodness, pi over 6, why is it still giving me these? It's so frustrating because what it will give you is it'll show you the different coordinates on the outside. So if I look pi over 6, that's 30 degrees. And hopefully now it will change it. Ah, perfect. Yay. See, persistence pays off. 1/2, root 3 over 2. So using my unit circle, I think, okay, both are positive. Woohoo. I'm going to put them in the first quadrant. Maybe I pick here. Oh, it says no. That's wrong. Try again. It even tells me what it is. All right, let's think. Remember, it starts at 1 on the top. 1, 2, 3. So I'm going to say it's here. Woo. Not bad, it's yellow because I didn't get it correct the first time. Again, as I go, I continue, it gives me feedback. Even if I get it really wrong, it says, oh well, use a hint. What I would like you to do is not to focus on the interior things, the pi over stuff, but get used to which ratio, sine and cosine, go around the circle. Feel free to do this as many times as you want, 2, 3, or 4, but minimum 2. One with your unit circle, and if you want and you're feeling gutsy, try without, but having your unit circle is perfect. All right. Okay, I hope you guys have a great lesson. Let me know if you have any questions. I'll be available all week at lunch. Okay, have a good day. Bye.